at the first rock unit. This is known as the Mission Valley Formation. It is primarily known as a sandstone. And if you look up the hill, you can see that we're actually on an area where the hill's actually relatively not that steep. You can see in the canyon, it gets a little bit steeper. And if you go a little bit further up the hill on either side of us, it also gets a little bit steeper. In the old days, there were geologists who would have done anything they could to destroy all the vegetation around us so that they could better map the rock units. A more evolved thinking on this is that the rock units often dictate what soil you get, and the soil is going to dictate what kind of plant life you get. And there's going to be places I'm going to point out later on this trip where you can actually basically name the rock unit by what plants are growing on it. You can notice also that right level with us is an area where there's a lot more grass on the hillside than either above or below. The sandstone here, the Mission Valley Formation, is known to be quite rich in clays. There's also the Friars Formation, which is also a clay-rich sandstone. In places like Santee, these clays, when they get wet, can make the formation very slippery. And some of these areas are known for quite a bit of landslide activity. We're going to run a couple tests on this. You can actually see some of the clay right here to sort of ascertain a little bit more about its mineralogy, its grain size, and other properties. There we go. We're rolling. Oh, yep. So one thing we're going to do here is whenever I see a whitish rock or any sedimentary rock, one test I love to do on it is pour a little acid on it. This is some vinegar. Oh wow, it is fizzing. Yeah, look at that, it is fizzing. This is just household vinegar. I know a lot of geologists provide hydrochloric acid. They're not wrong. It's just a little easier for me to get hold of kitchen vinegar than it is HCl, so we're working with what we got here. Yeah, it is really fizzing though. There's clearly a lot of calcite in here. Just remember, whenever you see calcite, there's a good chance, it's not a guarantee, that you're looking at lots of microscopic skeletons there. And here we are, aren't we wonderful people, breaking them down with acid. Oh, there we go. Now there's some fizz. Ooh, wow.
I can't zoom in.
Yeah, it's Steadicam. Yeah. It should still show up there, but yeah. So there we go. That's so we know there's a lot of calcite here. We're going to just take some. You can tell this stuff's fairly fine-grained. Not super fine-grained. This actually, I called this clay earlier. It's actually fine sand here. And you can see there's lots of lenses of fine sand in here. It's not, we call, often when you have a sedimentary rock where you have several different types of sediment all kind of intermingled, we call the different bodies of different sized grains lenses. Now another possible origin for this calcite is during certain climate regimes, climates that get a little bit hotter and a little bit wetter than San Diego, like say South Texas, often the soil in those climates will develop a very sort of like, if there's any calcium anywhere, you'll get this like very calcite rich hard pan in the soil. And because this has been exposed for 40 something million. So pick up where we left off, you have these little lenses. Again, what this might be is something called a caliche soil that formed at a later time. Well, I'll look, there's an outcrop of this. We might not be able to get there today, but I've got lots of pictures of it from previous trips, so
Okay.
we can supplement that.
The high is in the upper 60s, so it won't.
Year.